We're back in section 11.2. This is page 725, number 34. Don't do drugs. Cocaine addicts need cocaine to feel any pleasure, so perhaps giving them an antidepressant drug will help. A 3-year study with 72 chronic cocaine users compared an antidepressant drug called desipramine with lithium, a standard drug to treat cocaine addiction, and a placebo. 1/3 of the subjects were randomly assigned to receive each treatment. Here are the results. So they have the drug administered and then whether or not they relapsed. The first thing that we want to do is compare the distributions of relapse status for the 3 treatments. And then in part B, let me move that so you can see part B. In part B, we're going to answer, are there differences among the 3 groups statistically significant, and give an appropriate evidence to support your answer. So just looking at that, you can probably tell there seems to be a difference just in the number here of 20 relapses compared to 10 of them over here. We want to look at that mathematically. So the first thing that we're going to do is look at simply the two-way table. Think back to the probabilities that we worked on before. So if I'm just looking at my two-way table, I can see that with the desipramine, I had 10 out of 24 people relapse. That is 0.4167, let's say, who relapse, and this is just me doing it in the calculator. I had 18 out of 22 relapsing here. And then I have 20 out of 24 relapsing there. So if I just go off of those numbers, let me go back and double check I did those right. Oh, wait a second. 18 and 6 is actually 24, which changes that. 18 out of 24 should be instead 75% of them. Now that my numbers are better. So we can look at this and we can already see that this one here would be 83%. There's definitely a progression where the desipramine seemed to be working best, going back to our idea of probabilities. Notice I took the original data they gave us, I added my marginal distributions that we've looked at before. So to answer part A, patients who used desipramine had the lowest relapse rate of 41.7%, followed by lithium at 75%, and finally the placebo at 83.3%. Now, again, since we notice that this definitely seems to be working best, we want to answer part B, which was, is this statistically significant? To answer if it's statistically significant, we're going to do a test of significance. Again, notice that we are dealing with categorical data, multiple points of categorical data, so that should lead us to a chi-squared. Now, in 11.1, we did the chi-squared goodness of fit, but in 11.2, we have 2 different types of chi-squared. We have a chi-squared test for homogeneity and a chi-squared test for independence. In this case, since we have one categorical variable, which is did they relapse, and we're looking at it in 3 treatments, we should be using a chi-square test for homogeneity. So we're going to check the conditions for that chi-square test. We have 3 groups in a randomized experiment, and we're going to say all expected counts is greater than or equal to 5. Now I have that written in here, although I haven't shown that to you yet. We can go through as the book explains, and there is a calculation to figure out what those expected counts are, which is going to involve just multiplying things together and doing a division. But I'm going to kind of cheat this a little bit, and I'm going to use my calculator. So right now I have it written. If things go awry, then I'll go back and fix it. But since they did ask us to do the test, it usually means that we can do the test. So I'm kind of showing you how to cheat and shortcut this a little bit to save you time on your test. So for now, we're just going to leave that, and we're going to come back to it. We're then going to write our hypotheses. We have our null hypothesis. There is no difference in the true proportion of cocaine addicts, like these who relapse when using desipramine, lithium, or a placebo. Against, there is a difference in the true proportion who relapse when using these 3 treatments. And again, remember, you don't have to do any kind of fancy writing here. Go back to the question, and you'll find these words in the question. So once I have my hypotheses written, I'm going to go ahead and do some math here. I'm going to do the calculations. Now to do a chi-square test for homogeneity, I'm going to do similar to what we've been doing already. I'm going to go to stat, move over to test, and I'm going to go to chi-square test for homogeneity, which is just going to say chi-square test. Right away you see these things, observed in this and expected in that. You've probably never seen these before. That's the notation for a matrix. Most of you, I'm going to assume probably all of you, have never done or seen or worked with a matrix before. So this will be the first exposure to it. Basically, it's just a way that's going to let us put this categorical data, what's basically a two-way table, into our calculator. So over here on the left-hand side below math, I'm going to zoom out just a little bit so you guys can see what I'm pointing at. This button right here, notice it says matrix up there. So I'm going to go to that instead. So I'm going to quit out of this. I'm going to go to matrix. I'm going to move over to edit, just like we do with our list. We're going to edit it first, hit enter on A, and this is what a matrix looks like. I'm going to put my data into that matrix, and notice see I have it here already. Now 2 by 3 means 2 rows by 3 columns. It's a row by column matrix, so you're going to set that up first. Then if you just keep pressing enter, it'll work you through. So 10, 18, and again, press enter to get all that data in there, 14, 6, and 4. Once I have my data in my matrix, I'm going to go back to that test, go down to chi-square test. Nice thing about having this on a video, if that was too fast for you, go back, rewatch it. So my observed is an A. The calculator is going to put my expected into B. So you're not going to put anything there, just leave it for now. You're going to get that out of there later. And then you're going to hit calculate. So I'm going to write down what I just got on my calculator. Out of my calculator, it just told me that I have, chi-squared equal to 10.5. Remember, high chi-square means a low p-value, so that's a fairly high chi-squared right there. I get a p of 0.005, and I have a degrees of freedom of 2. Again, all of these things can be calculated by hand, but I can use my calculator to save me some time. Now I'm going to go back and check those expected counts. So second matrix, I'm going to go to matrix B now, and if I hit enter, that's my expected counts that my calculator calculated for me. We can see that all of those are definitely greater than or equal to 5, and I'm going to show that in my work here. I have 16, 16, and 16. I have 8, 8, and 8, and I'm going to say that these are my expected counts. Now, appropriate math would have me doing that first, but again, time-saving tip for you. So I'm going to write my conclusion based on that. Notice I have a low p-value. So based on that low p-value, I would reject my null hypothesis. So we have convincing evidence that there is a difference in the true proportion of cocaine addicts like these who relapse when using desipramine, lithium, or a placebo. Notice that was straight from what I had set up here in my null hypothesis.